All right. In this video, we're looking at example 3. I got a new pen, so you should be able to read it. Okay. So with example 3, we're dealing with a rational function. So this one will be a little interesting. Where are my glasses? There they are. Okay, so this one. Oh yeah, love this new pen. Makes it almost worth the money. All right, so in this example, we have a rational function. Okay, so that means you might remember that you're going to have domain issues potentially. You're going to have asymptotes potentially. So we're going to take a look at some of that. And then don't forget that I already worked out all the derivatives earlier. And you should have done the same and checked that so that we can make use of it without having to slow down to do the derivatives, okay? All right, so we're going to be pretty much using the guidelines in the book. They're similar to my template, but maybe just a tad more streamlined. All right, so you know that the domain of the function would be where the function is defined. And so what you got to watch out about is you know that that denominator right there can't be 0. So what you do to determine the domain is you set the denominator equal to 0. And you could factor, or you could have used the square root property, and then you find out that x equals 1 or the x plus 1 equals 0 would lead to x equaling -1, okay? All right, now, neither 1 or -1 makes the numerator 0. So these aren't going to give you wholes. You're going to have vertical asymptotes. These are going to be vertical asymptotes. So when we get ready to graph, okay, you're going to have some gaps. You're going to have some gaps at vertically at -1 and 1. Okay, so that's one of the things to keep in mind. All right, now, so the domain would be everything but that. All right, now, the next thing we could explore would be symmetry. But see how the numerator has a cube on it and the denominator has a square on it? That's not going to wind up having either type of symmetry. All right, and then our job was to get the derivatives. Okay, so we've already done that. So we know that we've got f prime already, we've got f double prime already. So f prime of x turned out to be, let me keep it in factored form, turned out to be 10x squared times the quantity x squared minus 3 over x squared minus 1 to the second power. And f double prime turned out to be 20x times x squared plus 3 over x squared minus 1 to the third power, okay? All right, so we were supposed to determine those, but we did that in an earlier video. And now we're going to wind up using these to figure out critical points and inflection points, possible maxes and mins, and possible inflection points, okay? All right, so let's take a look. So what you look for with the possible critical points is you're going to look for where does f prime of x equal 0, okay? And also where is it undefined? And so we already know it's undefined at x equals 1 or -1. So we already know that. So we wanted to find that. And then we also need to solve where does f prime of x equal 0. And remember, for a fraction to equal 0, the numerator has to be. So you wind up taking the numerator, the top part, and setting it equal to 0, okay? And when you do, you wind up getting that either 10x squared equals 0 or x squared minus 3 would equal 0. And so x squared minus 3 equaling 0 means x squared would be 3. So x would be positive or negative square root of 3. And over here, if you divided by 10, you'd still have a 0. So for x squared, 10x squared to equal 0, x squared would have to, and if you square root both sides, you're just going to get x is 0. Okay. All right. So we have a lot of critical points on this one because these right here are also usually things that you have to worry about as being critical numbers, but we already know what's going on there. Your function actually isn't even defined there. So we don't have to think about those as being possible maxes or mins in any way. Okay. So we have the 0, the positive or negative square root of 3, and we're going to check to see what happens around that function. Okay. All right. So that's what we're testing. We know that at 1, we're going to wind up having an asymptote there. And at -1, we're going to wind up having an asymptote there. All right, so I'm going to check at 0, see what's happening. I'm going to check between 1 and square root of 3 and between -1 and negative square root of 3. And then I'm also going to check way outside. Okay. All right, so let me go ahead. When I'm checking, I'm plugging into f prime, but then I'm going to interpret what it means for our function f when we're finished. Okay. So let's go ahead and think about if you plug 0 in, you're going to wind up getting, and when you're plugging it in, you're I'm going back up here and I'm checking just positives and negatives is all I really care about. So see how when you plug in a 0, the numerator would be 0, the denominator would not. Okay. So that means the whole thing's going to be 0. So this one's 0. We know that. Oh, I knew that. That was dumb. I shouldn't have done that. Sorry. Okay. I forgot that was one of our points, critical points. All right, so I already knew it was going to equal 0. All right, so actually I'm going to come over here to like a half and over here at -1/2, and I'm going to check those. Keep forgetting to bring my calculator with me. Oh, well. Okay, so we're going to think about plugging in a half and what would happen if we were to do that. And we're really just needing to think about positives and negatives. So if you take a half and you square it, okay, let me do this. So I'm looking down here, here, and here. If I take a half and I square it, I'm going to get a fourth. So this part would be positive. This part would be a fourth minus 3, so it would be negative. This part would be a positive 1/4 minus 1, which would be negative, but then you're squaring it. So the denominator would be positive. Okay. So if you have a positive times a negative on top, that's going to be negative. So it's going to be negative at positive 1/2. And negative 1/2 is going to give us the same thing, okay, because when you plug it in, you square it. So this is also going to be negative, okay. And then when I do the square root of 3, okay, when I do the square root of 3 and I square it, I get, oh wait, I don't want to do square root of 3. I want to be to the left of it. So let's get to like 1/2. Okay. So let's do like 1/2, 3/2. We'll test that. Okay, I already tested the 1/2 and the -1/2. Then I'll test 3/2. -3/2 will be the same. All right, so if I plug in a 3/2, that's going to get squared, be positive times a positive is positive. Put in 3/2 there. So that's going to be 3/2 times 3/2. That's 9/4. And 9/4 is not as big as 3. So that's still going to be negative. Okay. And then down here, you're going to take the 3/2 and you're going to square it. So that's your 9/4. That is bigger than 1. Okay. Which is positive, but you're squaring it, so it's already positive. So that's going to be negative. Okay. And then -3/2 doesn't change anything because you square it. So that's going to be negative. All right. Okay, interesting. All right, I'm just thinking about it. All right, if I'm over here, square root of 3 is about 1.7. So let me try plugging in a 2. We'll know what happens at -2. So if I plug in 2, that'll be positive. This will be positive because that's 4 minus 3. And this will be positive because that'll be 3 and then squared. So that's going to be positive, and -2 would as well. Okay, so now we know what happens in these different intervals. Okay, and you got to kind of break it up around the asymptote. Okay, so that's kind of what we know is going on. Now, what that means about f is what's important. So that means we know that f is going to be increasing, not necessarily straight and constant like that. It could be wavy, but it's going to be going up. And the -1 means it's going to be going down. Okay, this one's going to be down, down. Okay, this one's going to be down. So increasing, then decreasing, 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 and then it's going to be increasing again. All right, so one of the things we know based on what we've talked about so far is that point 0, which was a possible critical point, a possible extreme value, is not an extreme value, because see how it didn't change from increasing to decreasing around it? But this one is going to be a max. See how it goes up and then down? And this one's going to be a min because it went down and then up. Okay, so we do know these are going to be extrema, and we'll need the y coordinate at some point, so we could go ahead and do that at some point. I'm going to do it after we check inflection points. Okay, so we'll come back and we'll get this. When we do, we have to plug the square root of 3 into the f function, the original function. All right, let's get that far with the f double prime. All right, so over here, we already know, don't forget that x can't be 1 or -1. All right, then we're going to take the numerator, because we're going to look for what causes f prime of x to equal 0. So we're going to take the numerator and set it equal to 0. Okay, when we do, we have these two factors that could each be 0. And if 20x is 0, then we know x has to be 0. When we look at x squared plus 3, though, once we subtract the 3, we have x squared equaling -3, which means it's not a real number then. And we're looking for real numbers that, can show up on a real number coordinate plane. So this would be x equals plus or minus the square root of -3, and that's not real. Okay, so this right here is your only possible inflection point. All right, now we kind of know that's probably what's going on, because look over here at the first derivative. See how it went down and then down? Okay, but we also know, because if we take and we plug in, a number to the left of 0, and don't pick -1, I almost did again. Pick something somewhere to the left of 0, okay, somewhere to the right of 0, and plug it in and see what happens. So this is our possible inflection point, which we really are pretty sure it is. All right, when we plug it in, plug -2 in, what we'd have here is negative. This would be positive. -2 in there would be 4 minus 1, which would be positive. When you cube it, it would be positive. So overall, if you have a negative times a positive, that's going to be negative. So that's when I plugged in the -2. Okay. When I plug in the +2, then this is positive. So is that. So is that. So it's positive. So that means your f function is going to be concave down here, and you won't necessarily see the whole u. Okay, and then concave up here. And when your function, and that's not f prime, that's f. When your function changes from concave up to concave down or vice versa, you know that this right here really is an inflection point. So that is an inflection point. So we're going to want to know what corresponds with it, but we already know. If you plug in a 0 for x, you're going to, in the original function, okay, you're going to get a 0 on top and not get a 0 on the bottom. So 0, 0, that's going to be an inflection point. All right, and then these are going to be maxes and mins. So let's go back up to that original function and let's plug in the square root of 3 for each of those. Cannot read. There it is. Okay, so I'm going to the original function. Let me just scroll back up to it. Found my calculator. And we're putting in square root of 3. Okay, so I'm going to do 10 parenthesis the square root of 3. Okay, and that needs to be raised to the 3rd power. So I'll do that. That's on top. Okay, then I'm going to divide that by, and don't forget to put in an extra grouping symbol if you're trying to do it all in one step like I am. Then I'm going to do a left parenthesis, then another parenthesis to put the square root of 3 in. Oops. Let me get back where I was. Okay. And I'm trying to put, there I am, back where I needed to be. I'm going to put the square root of 3 in there. Okay. Square that one. And then take away 1 and then close that parenthesis so that you have the numerator being worked on, and then it'll divide what you get in that denominator. Okay. All right. When I do that, I got like 25.98. 25.98. Okay. And that's about 1.7. It's 1.73, yeah. Okay, and here we have negative about 1.73. And when you put the negative in, I'm just going to go back to my original thing and think about it. I'm going to get a negative on top and then the same thing on the bottom. So that's just going to make it a negative. So this will be negative 25. Well, that's backwards from what I'm expecting. Seems backwards from what I'm expecting. Because I'm expecting, based on what I'd got when I plugged into my first derivative, I was expecting that this would be a max, and that looks like it would be a min. Okay, let me check that. When I plug it in, I would get a negative on top. Yeah, so that would have been a negative. So let me double check my derivative. Make sure that I wound up plugging in and there wasn't like a negative out in front of that I forgot to write down. All right, so give me just a second and we'll double check that my derivative wasn't supposed to be negative or something to give us what I expected there. So I'm trying to do a rational function. Okay. Let's see, was that on? Give me a second. I don't want to have to start my video over. So let me just double check that. And then I'll reanalyze our signs just in case. All right, so when I plugged in the negative square root of 3, okay, first, my derivatives look okay. All right, and so let me go look. So I got it being a max. I got that being an inflection point. I got that being a min. What happens when I plug in square root of 3? Oh, it could be okay. I was bothered by this, but it could be okay because it's just a local. It's not a max max or a min min. It's just a local. So that could be just fine. Okay. All right. And if we needed an exact answer for this right here, we could get it by plugging in to the f function. So let me show you that also. Okay, so we could be okay. I mean, everything's seemed a little odd to me, but it just needs to be a local max. It doesn't need to be the highest of all. So this was your f function. I want to show you how to get the exact answer when you plug in square root of 3. So if you plug in the square root of 3 and you cube it, and then here the square root of 3 squared minus 1, it's easy to see what happens to the denominator. That would be 3 minus 1, which is 2. Right, on top, you'd have 10, and then really, remember that's 3 of these. So these two would become 3, and you'd have 30 square root of 3 over 2. So that would be 15 square root of 3 right here. 15 square root of 3, and it would be negative. Okay, and then over here, if I put in, over here, I would have had 15 square root of 3. And over here, if I put in a negative, that would just be, 3 negatives. So overall, I would get a negative on top, but no change on the bottom. And that's why I got a negative on that one. All right, so it always pays to double check, but we're good so far, okay? So we have the coordinates of our maxes and mins. We have the coordinates of our inflection point. All right, we have the vertical asymptotes. Okay, but the next thing on our guideline is probably to take a look at horizontal asymptotes. Let's check where we're at. So we've done the vertical asymptotes, but now we're supposed to look for end behavior, okay, or horizontal asymptotes, okay? So when we look at that original function, let's look back over here. See how it's bigger on top than it is on the bottom? Okay, so when it's bigger on top, the degree is bigger on top than it is on the bottom. And notice it's one more. That means you're going to wind up having a slant asymptote. Okay, so this is really, going to require you to do some dividing. So you'd want to divide x squared minus 1 into the 10x to the third is what you're kind of thinking about doing. All right, now, trying to think if there's an easier way to do it rather than having you do that long division. Long division is typically what you do. Let's go ahead and just do it so you'll see it. Okay, you need to put in a placeholder since the x term was missing. And here it helps to remember that you'd have a 0x squared and a 0x and a 0. Okay, so when you divide x squared into 10x to the third, it's going to be a 10x. Okay, you'd need another x, and you'd need the 10. When you multiply that back, that's going to give you the 10x to the third, but then you'll have plus 0x squared and then minus 10x. Okay, this is the part everybody misses when they do the long division and we have to do long division since you're dividing by a squared factor. So I'm going to subtract the 10x, subtract the 0, and add that. I'm going to go through. If I'm subtracting what you see in red, then I could distribute the negative so that I could just add straight down. So that's gone. That's just 0. And over here, I have 10x. And then I bring down the next number. Okay. All right. Well, at that point, I wind up having the degree here being less than what I have here. So, you're ready to write the remainder. So it's going to be y equals 10x plus, 10x over x squared minus 1. Okay. All right. So when you do that, the end behavior is determined by this right here. Okay. So as because this is just a rewritten form of f. This is really f of x. So if we looked at the limit of that as x goes to infinity, then we would wind up having the, this part would go to 0, and we would just get y equals 10x. Okay, so it's a slant asymptote right there at y equals 10x. Okay, so this one was kind of interesting. It had like all the things that could happen to you. So we're doing some hard examples, but maybe what you're faced with won't be so bad. Okay, so as x approaches positive or negative infinity, you're going to wind up having f of x approaching positive or negative infinity. It's going to be approaching that slant asymptote. All right, and then we did the places where the function was undefined already, but something else we want to do, I usually used to do it at the beginning, but since the guidelines have it near the end, I thought I'd wait. Another thing you want to know is where does f of x cross the x-axis? So f of x is going to equal 0 when the numerator equals 0, and that happens when x equals 0. So that's the only x-intercept is at 0, 0. All right, and then your y-intercept happens when you do f of 0, but when you do that, you also get 0, 0. Okay, so that's your y-intercept. And we kind of knew that once we wound up finding out that x equaled 0 when we put a 0 in for the y. And so since that was both the x and the y-intercept. Okay. All right, so you ready to put it all together? Phew, this was a long one. All right. I don't like how wiggly I did that. Let me try that again. All right, so over here at 1, we have a vertical asymptote. Over here at -1, we have a vertical asymptote. Okay, we have the y equal 10 to the x is a slant asymptote. Okay, now what that means is 8, 9, 10. It means when I'm at 0, I have a 0, but when I plug in a 1, I'd be at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that's not a point on the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. That's not going to be on the graph. This is actually, I'm getting ready to sketch where the vertical asymptote would be. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. So this is going to be a vertical asymptote. Okay. All right, now that is the x-intercept, and that's the only x-intercept. Then I have these two values that I can plot. The negative square root of 3, negative 25.98, and we'll just kind of ballpark that. So this would be over here at -2, this would be at +2, then negative 1.7 something would be way down. So if this is -10, I have to go to -25. So let me extend this out quite a bit. Okay, so if that's 10, this would be about 20. So, way down here when I'm over at -1.73. Okay, so I'm just kind of ballparking that. So negative square root of 3, and then it was -15 square root of 3, right? All right, and then this one, same deal, but I'm going to be way up here. If that's 10, this is about 20. It's going to be even higher than that, be way up here somewhere, and that's going to be the maximum value. So that's going to be where square root of 3, 15 square root of 3 would be. See, this is the thing that's kind of hard when this is why I'm picking complicated examples, is you can't necessarily see the complete graph. And zooming in doesn't always help. Zooming out doesn't always help because sometimes it zooms in both directions and you need to be more particular than that. So it really sometimes helps just to be able to analytically think through things. All right, so now let's remember what was happening. So let's go back up here. So when we're to the left of negative square root of 3, the function is supposed to be increasing. And when we're over to the left, left of 0, the whole thing is supposed to be concave down. So it's increasing but concave down, okay? And then see here how it's decreasing and concave down. So that's going to be pretty much a full circle. All right. So increasing and concave down, and then it's going to be decreasing and concave down. And we've got to hit that spot right there. So you've got to imagine this because we're way down here. So we're going to be coming in, okay, and it's going to wind up hitting, oops, there it is. I was looking at the wrong point. This is not really a point on the graph. So it's going to come in and it's going to hit that. And then that's it's decreasing because it's getting less and less positive. So the tangent line is getting flatter and flatter. Then here the tangent line is getting more and more steep, but more and more negative. So that's why it's considered decreasing. And that's an asymptote, so it doesn't cross that. It gets close to that. All right, now, when we're in between -1 and 0, let's see what's happening there. All right, so when we're in between -1 and 0, so that's in here, it's going to have to be decreasing, but decreasing and concave down. Decreasing and concave down. Okay, and that's when let me see if I'm right here. Okay, so it's decreasing and we're still to the left of 0. So it's going to have to be, I better check. I better split this just to be sure because that doesn't fit what I was imagining. I forgot to check in between these guys. So let me spread that out a little bit because I need to check. I forgot about those undefined values and they can really throw a wrench in things. So let me stretch that out a little bit and make sure that, let me see what's happening. Let's do that. Okay, and then this concave down and all, we were testing a -2 and we found out it was going to be concave down. So let me move that over a little bit. So it's down, okay? And then right there, I want to test, okay? All right, so let me check between so I know it's down to the left of -1. Let me check that little spot. I need to check that 1/2 right there, okay? And then I'm going to check the positive 1/2. All right, and what I'm checking it in is F double prime right here. And I'm checking whether it's positive or negative, so let me check that. All right, so if I do a 1/2 that's positive, this will be positive. 1/2 squared plus 3 would be positive. 1/2 squared would be 1/4. So that would be negative, and you cube it, it's going to stay negative. So this right here should wind up being negative. That's a -1/2. Let me get all that straight. Okay, so if it's a -1/2, then this is negative. That's positive. That's -1/2 squared. That's positive. Okay, and it's only a 1/4. When you take away 1, that's negative and you cube it. So we got a negative on top, negative on the bottom. So this is positive. But when you plug in a positive 1/2, then you're still going to get a negative down here, but this will be positive. Okay, which means overall, you're going to have a negative there. And then when we tested 2 before, if you plug in a 2, you wind up getting positive, positive, positive here. Positive, positive, positive. All right, so that's better. So now that's down, up, up. Okay. And I remembered to do that, or I caught myself because I know at 0, I have an inflection point. So there should be something interesting happening there. Okay. All right. So let's go back down then. We want it to be, we're looking at that stretch from -1 to 0. So we need it to be decreasing, but be up. Decreasing, but up. Okay. So decreasing, but concave up. Then from 0 to 1, we want that to be concave down, and from 0 to 1, it's still decreasing. Okay, so concave down. And the reason that's still decreasing is getting more and more negative. So the slope values are getting more and more negative, which means that it's decreasing. Okay. So this is less and less positive, which is decreasing, and then more and more negative, which is decreasing. All right, we've already got this piece down here. Remember, way down here, and I'm going to shrink this in a minute so you see the whole thing. All right, you can probably imagine what's going to happen to this other one. Let me go back and let's put that asymptote going up a little higher. Okay, and let's get that line y equal 10x. And on this part, this is when you're to the right of 1. When you're to the right of 1, you're to the right of, how far do we get to? Yeah, to 1. We're to the right of 1. So we're going to go from 1 to the square root of 3. We have to be decreasing. And then from square root of 3 on, increasing. All right. And from 1 all the way over, it's going to be up. So we know this is going to be doing concave up. So it's going to be coming in here. It's going to be decreasing. Do that in red. Because I had that up here. It's got to be decreasing, then it's got to be increasing, and it's got to be concave up everywhere. All right. So now let me shrink that because that turned out, see, we're doing these weird ones so that you can't just type it in to see it. Gives you kind of the reason you have to have kind of an analytic approach. Okay, there we go. You have to have kind of an analytical approach. So you've got some asymptotes on this one. So this is getting close to that asymptote. This is getting close to that one. Then you've got this piece, and this piece. And all three of those pieces together are part of the graph of f. Okay. All right, so that's a rational function. That was example 3 on the sheet. So I'm going to stop this, and then we'll do a couple more. This one took a while, and I'm trying to do quick, short videos.